Alright, let's look at the homework 7, problem number 4. Alright, so we want to find the interval of increase and the decrease and local extrema. Alright, so let's do that. Alright, let's find the derivative. So we have two things multiplied together, so this is a good place to apply product rule. Alright, so we have f prime of x is equal to, right, derivative of the first guy is 1 times the second guy is e to the negative 4x plus, right, first guy is x minus 1 multiplied by derivative of the second guy is e to the negative 4x, then multiplied by the derivative of the power, which is negative 4. Right? So if you clean this up, right, so you have e to the negative 4x, that's in common, so I'll pull that out. So common factor here and a common factor there, right? Then we have, so you get 1 from the first term, right? Then I'm going to distribute the negative 4 to x, so you get negative 4x, right? And then I'm going to distribute negative 4 to negative 1, so it's going to be positive 4. So I'm adding 4 to 1, so can I just erase that and put 5 there, because plus 4, 5 there. Alright, so if you set that equal to 0, and you can see that the exponential function is unfortunately always non-negative, it's actually positive there. Alright, so only way we can make this guy equal to 0 is you have x equals 5 over 4. So setting 5 minus 4x equal to 0, you get x is equal to 5 quarters. Alright, so if you do a number line, so you draw a number line here. Right, here is x. Right, so there's one critical number, so it's 5 quarters. Right. Then we can just check the sign. So f prime of anything less than 5 over 4, so I'll try 0. Right? So if you plug in 0 here, so this is going to be positive, so everyone's going to be positive. So you can see that the original function here is increasing there. Right? After 5 quarters, so we can try like a 2 or something like that. So f prime of 2. Right, if you plug in 2, 5 minus 8 would be negative, so this is going to be negative. So we know that the original function is decreasing on that interval. Right? So it's increasing before 5 quarter, after that it's decreasing. Right? So let's type it in. So increasing from negative infinity to 5 quarter. Right? So let's check the answer. Right? We got that. And decreasing after that, so you start from 5 quarter and then go to positive infinity. Right? So let's check the answer. Right? We got that. Alright, and let's see, function is, we're going to have, let's see, increasing turning into decreasing, so therefore we're going to have a local maximum at the 5 over 4. So we're going to have a local maximum, f of c is equal to, or actually, so no minimum, so only maximum here. So we have to find f of c, right? So c is in this case 5 over 4. So what is f of 5 quarters, right? So if you plug in 5 quarters minus 1, which is going to be 1 quarter, and then you have e to the negative 4 times 5 quarter would be negative 5, right? So it's going to be 1 quarter e to the negative 5. We can also write it as 1 over 4 e to the 5th power, right? So let's type that in. Right, so we're going to have only a maximum value, which is right here. Right, so value is 1 over 4 times e to the 5th power. Right, and let's check the answer. Right, ooh, actually, hold on a sec. What did I do? Oh, okay, sorry, I didn't round it to 4 decimal places. Alright, so I'm gonna have to do that, and I'm gonna bring out the calculator. Alright, so we need to do 1 divided by 4 times, and e to the, so where's the e? E to the 5th power, so e to the 5th power, alright, and then hit enter. So we need 4 decimal places, so it's a 0.0017. Alright, so let's type it in. We're going to have 0.0017. Alright, so let's check the answer. Alright, got that. Alright, that's it. I hope that this was clear.